Welcome to the DIY Honda Garage channel. In this presentation, we will address Diagnostic Trouble Codes, DTCs, P0962 and P0963, pertaining specifically to the Honda Civic models from 2016 to 2021. DTC P0962 indicates that the CVT drive pulley pressure control valve circuit is low, whereas DTC P0963 indicates that it is high. The continuous variable transmission, CVT, plays a vital role in optimizing engine performance by seamlessly adjusting the gear ratio based on driving conditions, making these DTCs critical for maintaining optimal transmission operation. Both DTCs signal an electrical circuit issue and are not related to mechanical failures within the transmission system. In this troubleshooting guide, we will explore error descriptions, causes, consequences, and step-by-step troubleshooting methodologies to effectively diagnose and rectify these issues, ensuring the vehicle operates smoothly and efficiently. The DTCs P0962 and P0963 are directly related to the CVT drive pulley pressure control valve's electrical circuit. The CVT drive pulley pressure control valve is a component that regulates transmission fluid pressure to facilitate shifting and control the belt's tension within the CVT. This valve is typically located within the valve body assembly of the CVT, specifically linked to the transmission control module, TCM, via electrical circuits that monitor its performance. Codes P0962 and P0963 indicate either an excessively low P0962 or high P0963 voltage from the valve circuit, signaling either a short circuit or an open circuit in the wiring or connectors. Importantly, both codes pertain to electrical faults rather than mechanical problems, which could potentially lead to transmission performance issues if not addressed promptly. The primary causes of DTCs P0962 and P0963 stem from electrical circuit problems that could impact the performance of the CVT drive pulley pressure control valve. These issues can arise from several sources, including poor or corroded connections that disrupt the electrical flow between the valve and the TCM. Additionally, loose terminals can cause intermittent connection issues, leading to erratic voltage readings that trigger these DTCs. It's vital to differentiate that the root cause lies strictly within the electrical wiring, connectors, or components related to the valve circuitry, as no mechanical faults in the transmission are responsible for these codes. A detailed examination is crucial to either isolate these faults or confirm connectivity integrity before proceeding with further specialized tests. When DTCs P0962 and P0963 are present, vehicle owners may experience significant symptoms that could affect overall driving performance. One common symptom is degraded transmission performance, which can manifest as slipping or harsh engagement during gear shifts. This can be particularly noticeable in scenarios where smooth acceleration is crucial, leading to a less enjoyable driving experience. Additionally, erratic gear shifts may occur as the system fails to accurately control the pressure required for optimal performance, causing the driver to feel unexpected lurching or hesitation. Most importantly, the activation of the check engine light serves as a warning that the vehicle's onboard diagnostic system has detected these issues, urging attention and timely intervention to prevent further complications. The first step in troubleshooting DTCs P0962 and P0963 involves verifying the presence of these codes through the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on mode without starting the engine. This action powers up the vehicle's electrical systems while preventing any unintended movements. Next, use the HDS to clear any existing DTCs, effectively resetting the vehicle's diagnostic system. After clearing, Start the engine and allow it to run for at least 1 second to gather new data. Finally, check the HDS again for either confirmed or pending DTCs. If either P0962 or P0963 is indicated, it confirms the fault is reoccurring, leading to further troubleshooting steps. However, if neither DTC appears, this may suggest an intermittent failure or that the system functions correctly at that moment. In the second troubleshooting step, we aim to pinpoint the possible failure area behind the DTCs. Start by ensuring the vehicle is turned to the off-lock mode to prevent any electrical mishaps during testing. Then, disconnect the TCM50P connector, which links the transmission control module to the vehicle's electrical system. This step is crucial as it isolates the TCM from the circuit, allowing for accurate resistance measurements. Next, measure the resistance between test points on the disconnected TCM connector and body ground. Specifically, you'll measure between TCM50P connector number 15 and a known good body ground. The desired resistance range should be between 5.0 and 6.3 ohms. If the reading falls within this range, proceed by consulting authorized service information or consider substituting with a known good TCM for verification. If the resistance is less than 5.0 ohms or greater than 6.3 ohms, further action is needed based on the specific condition presented. Upon determining that the resistance is less than 5.0 ohms, it indicates a potential short in the wiring. The third step involves checking for shorted wires in the DRLS line, which connects the CVT drive pulley pressure control solenoid valve to the TCM. Start this process by disconnecting the 2P connector of the CVT drive pulley pressure control solenoid valve. Once disconnected, check for continuity between the TCM connector number 15 and body ground. A successful continuity check suggesting that the circuit is compromised indicates a short to ground. If continuity is confirmed, immediate repair of the short circuit is essential to restore circuit integrity. Conversely, if continuity does not exist, this suggests that the DRLS wire is not the issue, which may indicate a faulty solenoid valve instead, leading to a recommendation to replace the entire valve body assembly for resolution. When the resistance measurement conditions indicate more than 6.3 ohms, the fourth troubleshooting step commences, focusing on checking for open circuits in the DRLS-DRC plus line. Similar to previous steps, you will start by disconnecting the CVT drive pulley pressure control solenoid valve 2P connector. Following this disconnection, check for continuity between the solenoid valve connector's number 2 terminal and TCM connector number 15. If continuity is present, this confirms that the wire is intact and you should proceed to step 5. However, if continuity is absent, this highlights a critical issue involving the DRLS-DRC plus wire, which must be repaired to eliminate the open circuit, preventing effective communication between the solenoid valve and the TCM. In the final troubleshooting step, addressing DTCs P0962 and P0963, we focus on assessing the DRC line for continuity. Ensure that the CVT drive pulley pressure control solenoid valve 2P connector and the TCM 50P connector remain disconnected to prevent erroneous readings. Check continuity between the solenoid valve connector number 1 and body ground. A successful continuity check indicates that the DRC wire is functioning correctly, thus suggesting that if DTCs persist, the solenoid valve may be the source of the issue, warranting its replacement. If continuity fails, repair any identified open circuit between the DRC wire leading to ground or address any poor ground connections to ensure effective electrical flow. Troubleshooting this last segment is vital to restore the vehicle's transmission functionality, as well as to effectively eliminate the root cause of the DTCs. After completing all necessary repairs for DTCs P0962 and P0963, it is paramount to conduct a final verification to ensure that the adjustments made have resolved the issue. Start by rechecking the DTCs using the Honda Diagnostic system to ensure that no fault codes reappear, verifying that the electrical circuits are now functioning correctly. Confirm that the vehicle operates normally once again, including consistent and smooth shifting, indicative of proper CVT function. Moreover, undertaking a test drive in various scenarios and conditions will help to validate that the repairs have effectively restored normal operation and that the DTCs are no longer present. This step is crucial to ensuring that the vehicle remains safe and reliable for everyday use. To proactively prevent the emergence of DTCs P0962 and P0963, it's beneficial to incorporate regular maintenance practices into the vehicle's schedule. Firstly, routinely inspecting the wiring and connectors associated with the CVT drive pulley pressure control valve can help identify any early signs of wear, corrosion, or disconnection that may lead to faults. Secondly, ensuring the integrity of electrical connections by securely fastening all terminals will help mitigate risks related to circuit interruptions. Additionally, servicing the transmission fluid periodically is essential for overall transmission health, as proper lubricant levels ensure that all components operate smoothly, reducing stress on the system. Engaging in these preventative measures contributes significantly to long-term vehicle performance and reliability. In conclusion, DTCs P0962 and P0963 pertain to electrical issues specifically associated with the CVT drive pulley pressure control valve circuitry in Honda Civic models from 2016 to 2021. It is vital to recognize that these codes highlight the importance of thorough troubleshooting processes to isolate and repair electrical faults, rather than misattributing issues to mechanical failures in the transmission. Through careful analysis and adherence to a systematic diagnostic approach, vehicle technicians can efficiently rectify these DTCs, ensuring peak performance of the CVT system. Finally, implementing comprehensive preventative maintenance practices will reduce the likelihood of recurrence, fostering a dependable vehicle experience for owners. Please like and subscribe to the channel. See you next time.